Hey, welcome back to Mechanical Pros. I'm here with Bill, and we are going to go through how to do pump selections using the Takeo Comfort pump selection software, which is free to use on their website. Tell me what we got going on here and what we need to know to do a pump selection.
Well, we're going to make a selection of several different pumps here. We're going to need to know what our flow rate is and what our head that we're trying to overcome with our pumps. On our first pump selection that we're going to look at, we're going to use a smaller pump. We'll go to the selection. We go over to the pump selection guide. It will give us a window here, and it will ask for our design flows. We're going to do a design flow of 80 GPM, and we're going to have a 22 feet of head. This is a fairly small pump. We use these pumps on our boilers. So I'm going to use a 1900 series pump, which is an inline close coupled pump. And you make a select, and it gives us a couple of things here. The one that I really like is this 1935 pump. And it gives us a curve right here. It also tells us that our operating horsepower will be at 0.69 horsepower. We have a net positive suction head of 3 feet. We are going to be running 1750 RPM. It gives an impeller size. It is 64% efficient. And it tells us our non-overloading horsepower is 0.77. And it says it's a 2-inch by 2-inch pump. So if we click on our thing here, it gives us that information on the side of this screen. We can double click, we can click again on the curve itself, and it blows that up. It gives you a curve line of the impeller size, which is the red line, and it shows where this pump will operate depending on the head. Now, this pump can only operate on this red line based on our selection. This curve is called a family of curves, and it shows each of the impeller sizes that the factory is putting on here for just a guide. I know that this red line here is a 5.35, and that's what it said on our selection. And it gives us a dot here of where we are. Now, on your pump curves, when you use this program, this pump is going to only operate along this red line. If you're at a constant speed, depending on your head, you will either go to the right if your head is less, giving you more GPM, or if you have a more head against it, it will be less GPM. This is the pump we usually use on our boilers, John. Mm-hmm. And it's right here in what we call the sweet spot. If you see this other curve, this is a system curve line that comes down, and you can see it's coming right straight down through the middle of this curve. In the very middle up here at the top of the largest impeller is 72%. And then we go down to 79, and anywhere within this line on the curve we're at 79%. We're down here close to about just above 65% on this. And it operates right there. I like this curve because we have a lot of variance with our head. It can show you what your flows are based on the amount of head, because there is some a good span here between what we call our shut-off flow or our shut-off head. At 0 GPM, we'll be sitting here at about 27 feet. And we're going to be operating over here at about 22 feet. So we've got about 5 feet of head difference that we can gauge this pump and know exactly what our flow is based on our differential pressure across the pump.
So being in that sweet spot gives you enough range either side of the curve.
Either side,
to be able to operate.
And the other good thing about it, John, is if you follow your red line out, it never crosses this 3/4 horsepower line. So it stays below the 3/4 horsepower. Mm-hmm. And that's going to be the horsepower motor that we put on this pump so that we're operating below the rated horsepower.
So, Bill, where do you find the information, the flow and the feet of head to be able to do a pump selection?
On most of our plans that we have, John, we're going to have a schedule, and it will give a design flow of what they want. And a lot of times they will give you a pump, but we like to go ahead and double check because there's a lot of different things. If we go back, now we have some other selections that we can do. If I change my GPM on another pump I was looking at was one where we have 225 GPM.
Okay.
And we're going to increase our head on this to 55. That's going to be more of a system pump that we'd be using, because I want to select an FI pump, which is a base-mounted end suction pump. We'll also look at a KV pump, which is our inline close couple pump, and we'll select here and see what they give us. Now, all these pumps will do that performance, John, but we want to look and see which one is the best. Now, what they do, they list these in the efficiency with the best efficiency first. I look to see more at the curve than I do the efficiency to make sure the operating part there. And also, I want to look at my pipe size. All right, with a 225 GPM, my system piping is going to be 4-inch pipe. All right, so if I got 4-inch pipe, I need to have a pump that will work well with 4-inch pipe. With the inline pumps, they're the same size whether they're on the suction and the discharge. All right, on the in suction pumps, we have one size larger on the suction than on the discharge. All right, we have a 4-inch pipe system more than likely, and with an FI pump, we have this FI pump 2510. It has a 3-inch suction and a 2.5-inch discharge, and we can adapt that pump to a 4-inch pipe connection through our suction diffuser, and have a reduction in our suction diffuser fitting so that it matches both the pump and the piping. And if we look here at this 2509 pump, right, we see it's right here in the middle of our pump curve, which is a good thing. And it is down here less than a 5 horsepower operating at non-overloading conditions. All right. I like this pump also because I've got a good pump line here. If we were to be using a drive, instead of working on the red line we see it, we'll be working on the blue line.
Okay.
That's how that works. And if we reduce the speed, we're going to reduce our GPM, and that'll also reduce our head. Now, when we use a drive, the reason that we're using the drive is we are going to vary the head in our system based on what's needed for that system. If we've got some equipment that has some control valves on it and they're closing, that will put more head on the system. So now we want to reduce the speed so that we keep our flow in the right proportion of there.
And it just takes you down that blue line.
It takes us down the blue line. And here again, I like to look at the non-overloading conditions so that we don't overload our motor just in case something were to happen and we go out too far. Our drive is another safety factor so we do not overload our motors. But these pumps are based on a constant speed, and this pump can only operate at a constant speed along this impeller line.
So what would happen if we were too far one way or the other on a pump curve?
All right. If we go to the right-hand side, John, what we're going to do, we're going to increase our amp load on our motor. As we get closer to our motor horsepower line, the amp goes up on the electrical usage, and that will work against your motor too. Is what it goes there. All right. Here again, this shows your flow, your head, your RPM, the diameter size of the impeller. The other thing the engineers don't like to see is an impeller that's close to full impeller size, because if there's a problem with the performance, you can change that by increasing the impeller size.
So it just gives you more flexibility.
Gives you more flexibility. Yeah. That way you have a pump that can be used, because a lot of times they may change part of the design later. They may not have the building completely utilized. Yeah. And if they add some more equipment, you may need to have some more pump. And you can do that by changing the impeller size if you have that available and still use the same pump. The other thing that we were looking at was if we go back, we had another pump type, which was the KV pump. And the pump that we'd need to use on that would probably be, if we look, we got a 3-inch pump, we got a 4-inch pump. When you're looking at this 4-inch pump, it shows it to have a 7 horsepower non-overloading, so you need to go up to a 7.5 horsepower, whereas on the other, you had a 5 horsepower on it. With the 3-inch pump, all right, see, we have a non-overloading at 5.26. All of our motors have a 1 0.15 safety factor. And you can also use your drive, if you have a drive, to limit the amount of horsepower that you're going to use so that you do not overload that motor. This pump selection here also is in a good spot in the curve. It is about in the middle, I like to stay right here in this middle somewhere. But even though it has these different percentage ranges, the middle of the curve is the best operating for your pump.
Okay. And then the other curves designated by the pump impeller diameter there. It looks like it.
That is correct. Every one of these lines, these are what we call a family of curves, and they put the impeller size. And depending on the impeller size, it will follow that same line.
Okay.
So if you had a 9-inch impeller here, and we had the same amount of head, this thing would be running way out here at almost 400 GPM.
Okay.
So that's how that works with impeller size and your GPM.
So it does give you some flexibility.
Versus the head. So that's what your factors are, is how much GPM you can push against a resistance, and that resistance is calculated in feet of head against the pump.
Okay. So when you get like a whole bunch of pumps, you do a search, and then it gives you maybe 20, 30 options to pick from. How would you start sorting through those and selecting the right pump or the good one that you really like?
The way I do it, John, is I look at where it is on the curve and how flat the line is. I'm going to take one more pump selection here. We're going to go up a little bit more and go up to 500 GPM.
Okay.
And we're going to go ahead and use the same 55 feet ahead. And because we're going to have a bigger pump, I'm going to make a selection of this KS pump, which you can change the seals on the KS pump without moving the motor. And as the motor gets larger, you want to be able to have some flexibility. And as I look here, the first thing I do, I look down through here at my curves, and I want to see which one has the best arc to it. Well, I was going to pick one that didn't have a good arc to it. Let me pick this one right here. On 500 GPM, we're going to be using 6-inch pipe is what our system pipe is going to be. And if I look down here, I've got a 5-inch pump right here that has a 6-inch suction. But if I pick this pump and look at this curve, John, this curve is flat right here.
Yeah.
If you've got a flat curve, you can't tell what your flow really is, because that's a differential pressure across the pump. And if we follow this line out and we get to along right here on this pump, on this curve, flow moves as you move across to the left, to the right, your GPM gets greater. So this is going way out past where we need to be. If this is 500, this is going to be 600, this is going to be 700. All right, so that's not a good selection for that pump. We go back to our
camera. Just turn it back on.
We go back to our chart and get back to our selections. The pump that we want to look at is 4009 pump, and if I look here, it's still close to this sweet spot.
Okay.
A lot of folks like to stay on the left of center. That doesn't bother me too much. The reason I want to stay on the left of center is we're going down towards our horsepower line. The impeller lines go across the page. The horsepower lines go from the bottom right up to the top left. And as this line comes through, we can see we've crossed the 7.5 horsepower line here, so we can't use the 7.5. We're more horsepower than 7.5, but we're less than the 10. So that would be our selection on that. And we're in a good place on the curve. This pump here does have a 5-inch suction. We can change again with a 6-inch by 5-inch suction diffuser to adapt to our system piping and help the contractor on he not having to make any changes in his piping sizes. We can make that change there at the pump. Okay.
Hey, tell me about net positive suction head.
All right, let me go back to this other thing here where it shows it on the curve, or on the selection part of it. It will tell you what you've got. This net positive section, I like to have a low net positive section on the thing, because with the low net positive suction, that lets you take that down to a less PSI coming into the pump. If that gets too low, you'll get cavitation in your pump. And what that does, you don't have enough pressure, and now your water is vaporizing in your pump. And it causes cavitation there, which can damage your impeller and your pump. So on a closed system, you don't have too much problem there, John.
Yeah.
But if you have an open system, such as a cooling tower loop, you want to make sure that you have a very low net positive suction pressure, or you could have some problems with cavitation in your pumps.
So in cavitation, you're spinning that pump faster than you can bring water to it.
It's taking the water out faster than it comes in.
You're pushing it out faster than it can come in.
Right.
And then you're basically just spinning your pump and creating air and all kinds of issues in the actual impeller itself, and that causes premature failures.
That's correct. You need to have that pump cavity full of water at all times. We do have some pumps at times I've seen where they will collect air in the top of the pump on the horizontal split case pumps. And if you have air in the pump, it's not going to pump water.
Yeah.
And so that can give you a very bad situation with that. If it is not determined that that's what the problem is and there's no one there to check things, you can boil the water out of the pump and create steam in the pump because you're not moving the water.
Yeah.
And as we look through here, we got a 4-foot net positive suction, but we also have one down here that is 18. All right. And it's way back on the curve too. So that's another thing that you don't like. But all these pumps will give you that GPM at that head based on what you have, but they're not all good selections. So they do list them by the efficiency first, and I look at the efficiencies plus where they are in the curve, plus what my pipe size is and my pump connection size to make sure that I've got enough pump to make this work economically with my horsepower of my pump.
All right. So and then what about efficiency too? I see you got, model horsepower, net positive suction head, or NPSH, RPM, impeller, and then efficiency. It seems like efficiency would be a big deal that, engineers would probably care about.
They care about that. The efficiency, though, if you look at what your horsepower rating is that you're running against, and it will operate in that efficiency. There's a range of efficiency right there, John. On this one right here, if we look at this curve one more time, you get a lot of information off of looking at these curves. When we see from this point here all the way over to this point here, we're in the same efficiency. All right, so we're going to we got a good range of efficiency in there, and it's in this top portion. It says 81, but 82 is the best you can do. Yeah. So we're in a good place in this pump, and it's going to work well for you. And all things work good when you're pumping your water at an efficient level, and your pump is working as it should. If we were to have a drive on here, that would be even better, and you get better efficiency the less horsepower that you're using on your pump. As we've looked at end suction pumps and inline pumps, there is one other pump that we talked about just a little bit, which was the split case pump. And if we jump this up and make this 1,500 GPM, and we're going to raise this head up to 70 feet this time, and we're going to add another pump to it, which is the TA pump, which is our horizontal split case pump, and select that. All right, and we have, it gives us an end suction pump. It gives us a KS pump, which is the inline pump. It also gives us this horizontal split case pump. Okay. All right, and it also gives us these RPMs. All right, what I want to do, it shows this TA pump here of a 2030 pump. And it shows it up here in a good efficiency. But it also shows it at 1160 RPM. 1160 RPM motors are more expensive. It's also up here on the top part of the curve. I I wouldn't select this one because of two things. One is the motor selection is not one that I really like to use because of that. You can't get to where you need to be. All right, so if I go back to my selection, I go down here to this next one, which it's a 1760 RPM. All right, and we see that it also is right here in a good place in the curve. All right, we've got a good line here to check in case we have some head. It'll let you know when you're not doing your performance because your head's going to change, and that'll show up in the pressure between your discharge and your suction pressure of the pump. All right, and here with the drive, you've got a good line here with your drive line where it will operate real well with the drive. And when I say that, that means this thing is fairly steep instead of a long line. All right, if you have if this thing drags out like this, it's not as good as having a good sharp line on your drive. All right, so this would be another pump that would be a good selection depending on what you want to do. This pump here is a 6 by 8 inch pump, so you got an 8-inch suction, you got a 6-inch discharge. With 1500 GPM, you're probably going to have an 8-inch pipe coming down to it. One good thing is to always have larger pipe than the connection of your pump. That way you've always got a supply of water available to come into that pump. Yeah. Like I say, the pump is pushing, it's not pulling. So you have to have a good supply of water coming into it in order to push it out. And that's where you get your net positive suction, is when it's trying to push out more water that can take in.
And you got a cheat sheet that tells you what the flow would be for the pipe diameter.
Yep. The engineers put out, they've got a chart that they use to determine what the pipe size will be for any flow in a system. Most of the time, if you have two pumps, John, if you got two pumps and they may have a smaller pipe in the vertical and tie into a common header of a large pipe. And that way, that also gives you another way of saving a little bit of money in the installation because you're reducing some pipe sizes. So a reduction in pipe size will be a reduction in your cost. Also, a reduction in fittings is a reduction in your cost. And we can provide reductions through our suction diffusers. And also, we can use a smaller triple duty valve on the discharge sometimes, depending on our pipe size and the pressure drop through our triple duty valve, because it has to have a certain pressure drop to operate properly. And you can have one too big and you won't get the pressure drop through it, so it's not going to be as accurate to get the flow. So there's a lot of things that go with the pump with the accessories, and that you can take that and help the contractor with his piping arrangement at the pump with your pump, your suction diffusers, your flex connectors, and your triple duty valves.
Awesome. So you got the pump that you want to use. What do you do in the software when you finally figure out what that pump is, and what is the next step?
The next step for me is to go into my pricing programs, and it's a different program. But this is very good on selection of your pumps. You get to see. You can also get from this program. You can get your submittal data for these pumps. Over on the side, you got submittal data, so you could pull submittal data up on this pump, and it's got several you can select from. We're just going to do the so this gives you a submittal data sheet on your pump, tells you all your stuff, also gives you your parts, all your replacement parts and everything. So there's this program here can give you a lot of information from about your pumps that you're using for this. So
click on that.
That's what I want. It went to the parts instead of into the submittal data. So here it is. It gives the pump dimensions. The other thing about these pumps, you can get these in either left hand or right hand rotation, or clockwise and counterclockwise. And it says on here that you're looking at it from the motor end. Now, this is good for folks in Texas because they can sit on the motor just like they're riding a horse. And so you're looking at it from the motor end, and it tells you what your rotation is, whether clockwise or counterclockwise. This is very, very important in the purchase of the pump. You can change it in the field, but it is not a pleasant job to do, to change in the field.
So you want to get your rotation
You
right.
got to get your rotation right on this, because the internals of the pump are backwards. You have to take the pump apart, take all the components off of the shaft and turn them around and put it back together there in the field.
So how would you know what the rotation needs to be just by looking at the drawings?
Well, you can see where your suction pipe is and your discharge pipe, and then you see if it's on the left or the right of the pump. And just like on this pump right here, we're on the motor side. All right, so our suction is coming down on the right side, and our discharge is going out on the left, as we're looking at it from the motor into the pump.
And then if you're doing a replacement pump and you don't have drawings or specifications or any kind of design, you need a picture or something to go off of.
The other thing is the suction will be one pipe size larger. So the larger pipe is your suction, the smaller pipe is your discharge. And that's on your in-suction pumps and on your horizontal split case pumps. With your inline pumps, they're always the same size in and out.
Okay.
And on those, you can tell that which is the suction, because you can see that the bottom where the pipe comes in on the flange, and you can see where on the bottom is larger. All right, that's where it's coming in, on that side where it goes down and goes to the bottom. Because on an inline pump, the water comes in and is drawn up through the pump casing, and then it's discharged out from the top half of the casing. So the suction is on the side that shows it going towards the bottom of the pump.
All right. So if you do pump selection, you print out the submittal data. You can give us a call or you can email it to us. We can give you a price for it.
Yep.
Give you availability, all accessories that go along with it. Everything you need from a hydronic pump standpoint.
Yep. And a lot of these pumps, we do have access to some pumps other than going through the factory. Like right now, everybody's got supply chain issues, but we have another source to where we can get pumps and build the pumps for the contractors if they're in a tight thing, depending on the size. Of course, they are limited based on size, but I have most of my inline pumps that I sell, I usually build them here.
Build them yourself.
Because we'll get the parts in for those and build them here. And we can have them within a week or two, usually, on some of the smaller pumps. Same thing with the smaller base-mounted pumps and the smaller inline pumps that we can do.
Well, that's great. Anything else?
Just if you have any pump need, just give us a call. We'll be glad to help you and walk you through anything with the software. It's a very good tool and very easy to use.
Yeah.
And gives you a lot of information and helps you to make the proper selection so that your system will operate properly.
That's great. Well, thanks, Bill. Fun to talk pumps with you. Always appreciate hanging out with you. And thanks for joining us. Hope you liked it. Hit that like, hit the subscribe, and we'll catch you next time on Mechanical Pros.